Okay, welcome back to episode 3 of writing smart contract with Mutan and the Go Ethereum client. We left it last time just after installing the client, and today we have Jeffrey joining us. Welcome, Jeffrey.
Yep. Thank you very much.
So, what are we going to do today, Jeffrey?
The idea that I had was we're going to create an altcoin. We're going to create our own currency, and we're going to call it Steph-coin.
Awesome.
So you're going to get your own coin. How's that?
To the moon.
Yes. Awesome.
Right, so we've installed, just to make sure everybody's on the same page, we have the Ethereum GUI running. We've installed, obviously, all the necessary software. Here it is, looking beautiful. And you were telling me earlier, Jeffrey, that this is going to change this interface, isn't it?
Yeah, absolutely. Ian, one of the graphics designers, is going to come over, and we're gonna redesign the entire thing. We're going to look at the browser. We're going to see how widgets can interact with the browser. We're going to see how we're going to develop and design the entire Ethereum browser and Ethereum App Store, whatever you want to call it. So the interface is definitely going to change. The interface that we're currently looking at is a test interface. It allows us to do sending transactions, creating contracts, and sending transactions towards contracts, and calling arguments on them. So that's it does the important thing.
Okay, can you give us a little maybe rundown of the various icons and what they do as of today? Obviously, we understand it's going to change, but for the purpose of today, maybe.
Sure. Yeah, absolutely. On the left here, you're going to have 3 icons. The top one is your the transactions that you have sent. It shows to which address it has been sent to, the value of it. The value, the denominators are going to change anyway. I haven't updated mine yet. These are going to change. So we have the value, we have the address, and whether it was sent to a contract.
Okay.
The middle one is creating a regular transaction, a simple send, as we call it. So you put in the address and the amount you want to send, and that's it.
Okay.
Then we have the contract part, which is the amount, the gas price, whether you want to create a contract or run a contract. When you run a contract, you get an extra field, which just specifies the contract address. And the largest field that you see on the screen is it can either be the arguments that you're gonna, kind of like the data that you send to the contract, and if you would put it on create contract, you can put the actual contract code in here.
Okay, brilliant.
And that's it. That's it. So then the last thing would be the I, and that's going to show you the blocks and the law. That's it. Nothing more.
Okay, and one thing that would be useful for our viewers is that this tab at the moment doesn't automatically refresh that well.
No.
Mine shows block 24, and I can see on your screen you're on block 34.
Yeah.
Even though that technically we're currently on 48 according to the console. Maybe you can show the console if you have it open.
Yeah, it's right here. It's kind of small.
Oh yeah, okay.
Let me.
There you go.
So we have 48. On top of here we have the miner. So the right on top is the miner that I'm currently mining at. The bottom one is actually Ethereum running there, and I have another one which is currently running on one of our servers, and that is just a node that you can connect to. The Go client will actually automatically connect to this one.
Oh, okay. So you're running 2 instances locally and 1 remotely then.
Yep.
All right, cool. Oh, brilliant. So for the purpose of this exercise, people don't need to mine; they just need to have the client open. And
that's it.
If there's not many people running that chain at the moment, is there a way for them to connect to maybe a peer and try it that way?
Oh, if they connect, they automatically connect to the seeding node. So you connect to it, and then whoever is currently connected to it, you will just get passed along and share each other peers, and then they will automatically connect to each other.
And here we can see you're running version 0.50, release candidate 4.
Yep.
Brilliant. Okay, well let's get started then.
Yeah, absolutely. I just want to show you a quick thing, and that is what we will eventually come up with. So I created my own coin, and we're gonna sort of redesign it and put your face into it, so you actually have Steph coin. So we have Jeff coin, and let me open it. So this is actually Jeff coin.
It's beautiful.
I know, it's pretty. So this is actually an external application. So what you can do is you can create your own contract, put the contract code into the network, and use HTML and JavaScript technology to connect to the Ethereum network and send transactions, get certain pieces of data, just full introspection. So
where's that? Is that HTML?
Yeah, HTML.
Yeah. And where does that live on a web server or?
No, it just lives as a local file.
It lives as a local file. How is it distributed amongst the people using?
No, it isn't yet. If you want to have, for example, you create your own Steph coin,
right?
And if you want to have someone else use the same interface, you just send them the file. That's how it currently works. There hasn't been, we haven't defined anything on how to distribute
yet
decentralized applications.
Got ya. So this is just a local file that talks to the underlying blockchain.
Yep.
And gives us a test interface to play with it.
Yeah, that's it.
Okay, cool.
So let's start by creating the actual contract.
Right.
For that, we need to have two things, because we want to bootstrap the Steph coin with an X amount of Steph coins, so that you can manage it and distribute it and send it to other people. So what we could do is we can create a piece of initializing code. That piece of initializing code will run when you send the contract onto the network. So a miner will pick it up. It will first try and run the initializing code. The initializing code will store a piece of just a number, and that number specifies the amount of value that your coin has as a limit. And what we do is we're saying that we want to store 10 to the 20th, and we want to give the value that, so in order for you, as in Stephan, so you can access it. And how you access it, we're gonna see how that works later. Just assume for now that we're gonna store 10 to the 20th into the local database of this contract.
Okay.
Why do I say local? Local database, because it's not really local, but the store is local to this contract. The only thing that can access it right now is the actual contract. So this .store says, I want to access my store. I want to access my database, the database that is connected to this contract, so to speak.
Okay.
And it is a simple key value storage. So the key would be the origin. The origin would be you, the person that is creating the contract.
Right.
And the value, obviously, is this bit. And that's the only thing we really need. So if I were to send this contract onto the network, a miner will pick it up. It would see this piece of code and say, okay, well, I'm going to execute it. And what it will do is it will store this amount into the store of this contract, and the value belonging to it is the originator. It's the original one, the person that sent it onto the network. But by this alone, we don't have a contract. It's not going to do anything besides just sitting there being pretty. We need actual code for it to, actually run. So if we send it a transaction, it's going to do something. It's going to do something meaningful, because right now it's not going to do anything at all, because it doesn't have something called a main. So what the main will do is it will represent the actual contract, the piece of data that will be stored onto the blockchain, and it is going to live there, and it will execute if someone sends it a transaction.
Okay.
So what we want to do is, for your coin, in order to send someone a piece of Steph coin, if you want to send some Steph coin to someone, what we're going to do is we want to specify someone's address, for example, mine, and we want to have a value, because that's the only two things we really need. We need to know the recipient, and we need to know how much we want to send to that person.
Okay.
So what we do is, as I explained earlier, when you run a contract, you can send it like arguments. You can send it arbitrary data. That arbitrary data we can actually read out. And how we can read it out is with something called this.data. And the data is also, again, a key value or like an array. So if we want to access the first element of that piece of data that you send to it, you would just, like regular programming, like how you would access an array, just give it an index, and it will return that piece of information that was stored at that index. So what we do is we store it into a temporary variable into the memory of the VM that will eventually run it. So we just store it here temporarily so we can access it later. The second thing that we want to have is who's going to actually send this transaction. So if I want to send you some Steph coin, or you want to send me some Steph coin, we need to subtract that amount from someone's wallet to the other person that you want to send some coin to.
A bit like a bank?
No, not like a bank, but more like just a money transfer. So you have 10 Steph coin, and you want to send 5 Steph coin to me. So what we do is we reduce them from yours, and we add some to mine. Very simply. So what we do is we check who the actual transactor is, which is the origin. It's me or it's you. We want to see what the value is. So what we do is we access the first, or actually the second index, the second element into this array. We store it in a temporary value so we can access it later. So what we're going to do now is we want to make absolute sure that the person that instructed this contract, that want to transfer some money, some Steph coin, we're going to make sure that that person actually has the amount that it wants to send. Because if it cannot send the amount, then the transaction is obviously invalid.
Right.
Correct. So by specifying an if statement, we say if the person has more value in his account or equal to the value that it wants to send, we can continue on and execute as the contract specifies. So I want to do in this piece is we just simply want to reduce from the person that sent the transaction. We want to reduce the value. So we just subtract the value from the person's address. Now we want to store it to the person that we want to send it to. So what we do is we add the value to the person that sent it to. So the two over here that we specified here, this is a piece of information, it's a piece of data that we want to send to someone. So for example, I just have to copy and paste the address real quick. That is yours.
Oh, beautiful.
Yeah, that was you. So for example, we want to send you some Steph coin. We can put in your address, and then we can put in the value. This one over here is the first value in the array. So that would become 0. This one would become the first one. As you can see here, this dot data and access the first element in that array, that would be your address. Then the second one, the second index into that element, would be the value.
Okay. I think for the benefit of the viewers, there's a couple of questions I already have, I'm afraid.
Sure, yeah. Go ahead.
So I guess that would sort of suggest that the order in which data is organized when you send data to a contract, send a transaction to a contract, does really matter, because obviously can't flip the field. How does one know in what order to send the data. Say the contract accepts 10 different variables. How do we advertise that fact?
Well, obviously, to be honest, I don't think anyone is just going to send raw data to a transaction. You would usually do that through, like what I showed earlier, through
An interface.
Like an interface, because you would, for example, the receiver's address, I would just put it in and then the amount. But underneath, it's just going to combine that data and send the actual transaction to the contract. You're not going to bother with specifying like the first one. Which one was the first one? Oh yeah, it was the address, and then we have to figure it out. You don't want to do that,
right?
You want to create a pretty UE for your contract, and as simple as a coin. You can create a real quick.
Okay, and then the second question, then probably a little bit more syntax oriented. This is Go code, right? It's Mutan.
More or less.
More or less, yes. And what about race conditions? Because here you're running two actions. I don't see any concept of transaction and rollbacks and so on. How does that work on something like Ethereum? We don't have to worry about it because it's a single thread and every transaction is processed in the order they arrive or something like
that? Well, actually, no. The miner decides in which order the transaction is going to be executed.
So there can't be a race condition, but there could be a situation by which the miner could decide in which order things have arrived.
Yeah, absolutely.
Gotcha. Okay, cool. So let's recap on the code itself. Mm-hmm. The init block is executed once. Is that correct? When the contract is created.
Yeah.
And that first line, this does store, and then the array, and this value 10 to the power of 20. Mm-hmm. That defines. What does that define actually? It defines this number represent how much storage is reserved, or
no. Okay. So you're going to create a contract. Mm-hmm. The contract creator would be the origin.
So that's my address, right? That's my Ether address.
Yeah. Let's assume this is just to make it. I was going to say to make it look more readable, but it's not readable at all. Gotcha. Let's leave it at that.
Yeah.
So this dot origin would be Q. Mm-hmm. This is U. So what you do here is you would store the key of the store. It's going to hold 10 to the power of 20. Mm-hmm. So what we could say is you hold 10 to the power of 20 Steph coin. That is the
right. Okay, got it. Yeah, okay.
So you just bootstrap your coin. You're gonna hold 10 to the power of 20.
Hooray! That's a lot.
So you have a lot of Steph coin.
That's brilliant.
Because it has to for the simple coin is this we need some bootstrap coin. We're not gonna create a sophisticated thing. We're just gonna create something very simple.
Gotcha. And
actually on the back of the T-shirts that we have. This is the contract.
That's right. Okay, so that's brilliant. And then in the main, that gets executed on every transaction.
Yep.
And for every transaction, it's defining a set of variables, I suppose. And those variables are for convenience only. I imagine you don't need them. You can just use them.
Yep.
Yeah.
You could use it directly.
Okay, yeah. and big is a big integer, right?
Yep. Okay. So.
Okay. And so in my to field, it's who I want to send the money to. In my from field is the address of the sender, and the value is the amount I want to send. And then
wait. So the from is the person that sends the transaction.
That's right. And then to is the person I want to send to, of course. Mm-hmm. And then we do a quick check to see if the person actually has the necessary funds to send this value, and if they do, we subtract from one and add it to the other. So it's a key value pair store, so to speak.
Exactly. That's it. Very simple.
Brilliant. Very, very easy.
Yeah. So if I can...
There's a little typo there. It's from, not form. There you go.
You're good.
Oh, yeah. Eagle eye, Stephan.
Yeah.
Brilliant. Oh, that's pretty easy.
We have actually, because I use bigs here, and just assume that everyone knows what a big is, but we actually have a couple of times. We have the smallest one is actually an 8-bit integer.
Okay.
It's 1 byte. You could also write that as a byte. We have an 16, we have 32, and we have 64, and then it goes up to 256, which would be a big.
So it sounds like because people pay for that storage, right? The contract pays for that storage, yeah?
Yeah, the memory.
So you're better off using the smallest possible container, so to speak, to store the data, right? To save money, is that correct?
Yeah, so if I were to specify, for example, something as a int 8, and I only have to put something that is lower than 255, then we can do something like 10.
Right.
You know, I could, if I wanted to, I could do something like that.
Uh-huh.
But there's no, it doesn't make any sense to do that.
Right. So the compiler clever enough to try to minimize the footprint of a contract by checking the maximum size of the? Well, they can't really because they don't know what data is going to try to come in, right?
No.
Right.
For example, if we were to have a for loop, we can't optimize that. Well, we could, but that takes an enormous amount of time. And
Gotcha.
And it's still a work in progress.
Of course. So people will have to exercise judgment and use the right data sizes for each variable.
Yep, true.
In order to, that makes sense. Okay, great. Well, I understand, so we can move on.
Okay, good. So, so now we have the actual contract, and if we put this onto the network, it should actually work.
Wow.
I'm just gonna make sure that I have to. Things good. So if we broadcast this onto the network, we're gonna have a contract living there. It's gonna store 10 to the power of 20 into the original account, which would be, if I send it, would be me, but if you were to be, it would be you.
Mm-hmm. So I'm going to press send, right?
You're going to press send, you're going to send it over to the network, and you have your contract. That's it. Well, obviously, you need to put in some gas, or just put in the max.
All right, so explain to us what is gas.
Right. So we have gas. See it as like a car. A car needs gas to operate, to run. If you want to drive the car, you need to put some gas in. The car will take you until it runs out of gas, basically.
Right.
So the contract works as in the same way. You kind of say, like, I want to spend 100 gas on this contract, and I offer a price of 250, so the gas price would be 250. So it would be 250 times 100, and that is the maximum amount of gas that you want to spend on this thing. Okay. So for each instruction, for example, if we're going to go down to the assembly language real quick, give you a very simple example, which would be push. What push does is just pushes a value somewhere into the virtual machine, and so the virtual machine can do something with that value. It doesn't matter what it needs to do, but just let's assume it does something with the number 30. Okay. In order to push the number 30 onto the stack into the virtual machine, it uses an X amount of gas. And for example, in the case of push, it uses 1 gas. So what you have to pay for that is 250. Okay. Because 1 times 250 is 250. That's right. If push 1 would cost 2 gas, you would pay 500 for it, and so on until you run out of gas, and that's it. Then it stops. So either way, you have to run out of gas. The contract stops working. For example, if we say stop, then the contract stops as well. Or if we just simply end the execution of the contract, it will stop as well. Okay. So when I'm typing those numbers, when I type 100 ether and 250 gas, 250 gas per ether. 250. 250 is the gas price, so you would pay 100 times 250. Okay, got ya. And where does that money go to? I mean, is that subtracted from my ether account? Yep. So if you create this contract, it kind of gets converted. Your ether gets converted to gas, and that's it. So the miner is going to run your contract.
Right.
It's gonna convert your gas to, or your ether to something that it can work with,
Right.
which is gas in this case. Then, for example, it only needs 20 gas, so we're left with 80 gas. Where is it going to go? The 80 gas that's left, that is not being used, is simply being returned to the person that sent the transaction, which would be you. So.
Oh, okay. So by putting the maximum, because I wrote my own code, I'm not taking any chances because I know my code is okay. And by putting the maximum, I don't risk paying tons of ether, right?
No, you're not. You're just, the only thing that it needs to do is it only needs to create this bit, and
Right.
it's gonna use some value for creating the contract, executing, or sending a transaction.
Right.
It's gonna need some gas for the actual storage of the contract.
And those values are defined where? In the white paper?
Yeah, it's defined in the white paper.
Right. So, and are they
both in the white paper and yellow paper? I'm not sure about the yellow paper, but
okay. And let's move on then. I'm gonna press send.
Yep.
Okay, I'm pressing send. That's very exciting. I've never done this before.
So we press send.
Okay, so it says I'm looking at my console now for the people who. Oh, you press send or did I press? Oh, we both press send.
Yeah, I press send as well.
Okay, so we both have a coin.
Mm-hmm.
Okay.
So now the contract actually, you create a contract, and the contract is going to have an address that you can send transactions to in order for it to run. Now the address that you see here, your transaction has been submitted, and then you see a number here. That is the address of your contract.
All right.
So if you lose it, you lose it. You're shit out of luck, and
don't lose it. Don't lose
this
address.
Don't lose it. Absolutely don't lose it. I'm just gonna see and wait until the contract has been created. Good. The miner picked it up, and in the block got submitted everywhere. Yeah, good. So now we actually have a coin now, which is kind of cool. We have a coin. So what we can do, we can actually. Now we can send something to the. You know what? I know something better. I'm just gonna edit Jeff coin. Just gonna edit Jeff coin real quick.
Right.
Put in the new address that we just from the contract.
That's the web page that we saw earlier.
Yep. So this is the HTML view of Jeff coin actually.
And that's on your local machine, right?
This is on my local machine. Actually, it is in the. It's in the repository. So if you need an example, you can use this.
Cool.
Let me see real quick. Does it work? Yeah, it should work. Okay, so I put in my the new address that I use. And don't worry about the code that's specified there. Just assume it works. If you wanna look into the code, you can just go to the repository.
We will.
And you can just fork it.
Awesome.
Something. So we have our new Jeff coin.
Brilliant.
It read out the amount that is in my account, and in my account only. No one else has it. So yeah, if you would just add it, we just change the address to what I pasted to you. This one in the HTML file. We can read from the same contract, because the one that is currently in is of an old Jeff coin in another blockchain, an old blockchain that we killed already. So if you edit it, then you can read from the same database as I do currently.
Okay, I've just updated the file, ready to go.
Okay, cool. I'm gonna send you some coins now.
Mm-hmm.
So I'm gonna do that now. I'm just gonna send you 1,000.
Thanks.
It's gonna worth a lot. I'm making you rich. Anyway, so I'm gonna send it to you, and your GUI should update as well. So I mean, we just have to wait until it finds a new block, because the contract has to be. So you can see here, it's being processed by the miner. Now it's gonna find. Now it's gonna look for a correct nonce.
And while we wait, this stuff we're seeing on screen is the assembly code, that
Yep.
the conversion of what we typed in Mutan earlier.
Exactly what I said earlier. We had like a push, and I did. Well, here it is, push one. That cost money.
Gotcha.
So we have some debugging here, and now it's working out the hashes, brute forcing it.
Yeah, it's just good time to remind people that this is a testnet. There's no point mining except for helping out with the building of the network, and that the proof of work algorithm we're using is temporary.
Yep.
It's
Correct.
not the final one. I just saw something.
Yeah.
Yep. So on my console, I can see that it's running closure XYZ, and I can see the same assembly code that you have on your screen.
Yep, that's it.
And my GUI has updated, yes.
Exactly. You have 1,000 Jeff points.
Wow. And you have 1,000 less, apparently. Your GUI has also updated.
Yep. So you can see here we had 10 to the power of 20 earlier. Now it's subtracted 1,000 from mine and added 1,000 to you.
So it might be worth if you showed us the HTML code, so people understand how did that work. I mean, you got obviously some type of JavaScript binding or something.
Yep. We can go over it really quickly. Let's forget the transaction part for now. Let's just focus on the initialization of the contract first. What we first have to do is we have to request the current key, your private key that you use to assign transactions.
Okay.
So what we can do then is turn it into an address, because that's what we used for the contract. We're going to show you some of that, what we did earlier. We had, let me copy and paste it real quick. We had this bit. Let me see. Yeah, this one. The origin. It's the same as saying, where is it? This one. So we can convert a secret key, a private key, to an address, which would be the origin, and if we send a transaction to it. We can retrieve the storage from the Jeff coin, the contract that we created earlier. This is the coin. We can get the storage from that. We can read it. We can read our own address, this bit. So we can read this part directly from the contract, and we can see what value is stored in that currently. And we just update our current amount, the storage, to that. So what we get is this bit. This bit corresponds to this part of the code.
How is that? Did you have to refresh the HTML page, by the way?
No, it does it automatically. So what we do, I'm going to get to that. We have a function which is called watch. So what you can do is you can watch for a specific address and specific storage space in a contract. So what we can do is we want to watch in the Jeff coin storage, which is this part, and the part that we want to watch, that we want to observe, that we want to have changes on, is the address that I currently own. Is that clear?
Yeah, very clear.
Okay, so once that, for example, if something gets subtracted or added to my account, the JavaScript is going to be notified of the change,
right?
And it's going to show you what the value of that change is.
So watch is a bit of a loop, right? Technically, you just constantly. Do you constantly query, or do
no? It works like a callback. So
it's a callback.
Yeah, I notify my client that I want to receive notifications of whatever address that I specify. In this case, the Jeff coin address, and I want to observe the address space that I own, basically. And if something happens to it, it doesn't have to query. It's just going to be there. And if something changes, Ethereum, the network, the Go client is going to notify your application, so you can act upon that.
Oh, very cool.
So there's no looping involved, no nothing.
It's most like reactive programming, almost.
Yep, absolutely.
Yeah, very cool.
So the Go client actually has we build a reactor pattern kind of thing, and you can also use the same functionality inside the Go client. So if you were to use if you want to do Go development and you want to leverage the Ethereum network, you can just link against or use the package and use the same principle. It's kind of nice.
Brilliant.
Yeah. Okay, so once something changes, as you saw here, I subtracted some from my value and added something to yours.
1,000, yeah.
And that's why you saw your change, and that's why I saw my change. That's this bit. 3 lines of code, actually 2. That's it. That's the only thing you need.
Yeah,
Quite convenient.
Very easy stuff.
Yeah. So what we then have, if we want to send a transaction, that we did earlier. So if I want to send you another 1,000,
Oh, wow.
it's going to run this bit.
It's my lucky day.
Yeah, I send you money, man. So we have the create transaction method. And what it does, it's going to subtract the address, this bit, and it's going to read the amount, which is this bit. And what it does, it's going to pad it with zeros. So the Ethereum network is going to understand that it's, it's just going to put it in the right format. Let's leave it at that. And it's going to use that data. So we're going to use the address and the amount, which was specified here. So this.data is the first element, which is this one, the actual address, and the value. That's the second one, and that's that bit. So we can use those 2 fields, and we're going to use them directly in our contract. And we know from to whom we want to send and how much we want to send to.
That's super straightforward.
And then we're going to create a transaction. We create a transaction out of that, and we're just going to send to Jeff Coin. And that's it with the data that we specified into the fields.
And these bindings, are they documented anywhere?
Yep. So we have on our wiki, we actually have the JavaScript API, and everything is documented. We have the Ethereum API, so we have get block, transact, create, get key, etc., etc. So all the things that you're likely needing, you have it right there.
Brilliant.
You can use it now. You can use it already.
That's wonderful. Well, I think we covered. We're running on to almost an hour now.
Yeah.
I think we covered enough ground. And so, if there's nothing else, is there anything you want to show, Jeffrey, before we go?
No. If you have any questions, maybe I can answer them now.
No, I'm all good. I think we'll link back to the forum, so forum.ethereum.org for every questions regarding writing in Mutan and as well as in LNL and Serpent, or 2 other smart contract languages. We created 2 new categories today for that purpose. And if you're interested in learning more, and if you're based in London, we're also running hackathons starting on the 24th. The first one is already fully booked, but there'll be plenty of others. So have a look at meetup.com/Ethereum, and you can find more hackathons ready for you there. Thank you very much, Jeffrey.
Thank you very much. And you're welcome.
Bye-bye.